Okay, let's learn how to express a system of equations as an augmented matrix. So here's what we're going to do. We're going to understand what augmented matrices are, or what an augmented matrix is. We're going to also look at the steps that we want to follow to write a system of equations as an augmented matrix or in augmented form. And then, of course, we're going to do some examples together so you can see how to apply these steps to real examples. Okay, what's an augmented matrix? An augmented matrix for a system of equations is a matrix of numbers in which each row represents the constant from one equation, and this must be from both sides of the equal sign. So let's go ahead and talk about the steps that we need to follow to write an equation in augmented form. First of all, you want to make sure that you set up the equation so that the variables are on the left side and the constants are on the right side. So variables are on the left side. So this is your equal to right here. You want variables on this side and constants on this side. So you have to rearrange all of them, all of your equations, so they look exactly like that. And then you're going to draw a vertical line to represent your equal to, and you will see why that's important. Now we'll create a matrix by using the coefficients of the variables on the left side of the vertical line and the constant on the right side of the vertical line. Each equation in the system must represent a row in the matrix. So let's put all of this knowledge to action. So here's the first one. Express the system of linear equations below as an augmented matrix. So let's draw our matrix symbol right here. So the first thing we're going to be looking for is to make sure that all our variables are on the left-hand side of the equal to and our constants are on the right side. We have exactly that. So we're going to represent a line. Let's draw a vertical line. So this is going to be our equal to here. And then I'm going to draw a vertical line here as well. And so we have 2x and 3y. So this is going to be our x, this is going to be our y, and here's our constant, just for you to say it. So this is going to be 2x and then 3y, and this is the constant. The second one is negative 5x. We have y, the coefficient of y is 1 whenever you don't see any number to the left-hand side of a variable. You can safely assume that it's 1, and then here you have 9. So this is the augmented matrix for this system of equations. Let's try another example. Express the system of linear equations below as an augmented matrix. We got negative 3x plus y minus 8z equal to negative 11. 4x plus 2y minus z equal to 9. So let's go ahead and express this as an augmented matrix. We start off by drawing our matrix symbol. I'm going to draw my vertical line to represent equal to. And this is going to be x, y, z. So this is negative 3, 1, negative 8, and this is negative 11. The second one is 4, 2, negative 1, and then we have 9. So I hope it's making more sense as we go through these examples. So now let's go ahead and write this system of linear equations as an augmented matrix. I'm going to draw my vertical line to represent equal to. So you have to first make sure that the equations look the same. Remember that they must look the same. So you have x, y, z, and then we have constant. So we have negative 3, we have 1, we have negative 8, we have negative 11 over here, we have 6, 3, negative 2, and then we have 19 over here, and then we have 5, negative 7, negative 6, negative 8. So this really shows you how you go about writing your matrix in augmented form. Let's do one more example, just for good measure. Okay, so you can see now we have a unique situation here. We have x and y on the top for the first equation, x, y, z for the second equation, and then we have x and z for the last equation. So what we're going to do now is we're going to rewrite all the equations so they look the same. So we know that our variables are x, y, and z. Okay, so we have 5x plus 9y plus 0z equal to 8. The next one we have 4x plus 2y plus 11z equal to -5. The second one we have x, and then there's no y here, so we're going to say plus 0y minus 3z equal to 1. So now let's write this augmented matrix. We're going to draw a vertical line to represent the equal to. So we now have 5, 9, 0, and then we have 8 over here. Then we have 4, 2, 11, and we have -5. And then we have 1, 0, -3, and then we have 1. So you've seen all the different instances or all the different type of examples that you can create for linear equations, so you can write them in augmented matrix or as an augmented matrix, or you can